Let's look at this next question here. This looks like general reduction. If I see a 2x and a 2x here, it's a grade 12 question because there's a double angle identities in it. Let's just try this. The cos of 360 plus x, well, that's the first quadrant. You got to know where it is, 360, and it bends in it. So it's just the cosine of x. This one here, 180 minus x, that's the second quadrant. That must be negative tangent. This one, the cosine of minus 2x, that's bending down. In there, I think it must be negative sine 2x, just what Mr. Autry has. But the cosine of minus x is in the fourth quadrant. It must be cos x. So that's why you've got all these values here. And the sine of 90 plus x, that's the second quadrant, and it's a cofunction problem. So the sine of 90 plus x is the cosine of x. Well, there's the first steps, everything all done. But tangent is sine over cosine. We're supposed to know that. Tangent is sine over cosine. And these two negatives just make a positive here. That's sine over cosine. That's sine of 2x, though. There's a formula, an identity in the sheet, and you can rub out the sine of 2x and put in 2 sine x cos x. And you've got a cos x on the end. It's cos x minus this. Those just turned positive. Well, look at this here. See, one of these cos x's is going to cancel here. Sine times sine is going to give me sine squared. So we've got it cos in 1 minus 2 sine squared times cos. Well, it's time to factor out the cos x. And 1 minus 2 sine squared, that's another identity. It's just a formula on your sheet that you're given, but you should have done enough questions to know that 1 minus 2 sine squared x is really equal to cos 2x. And this cos x canceled with this. And isn't that what we were trying to prove? We're trying to get cos 2x all by itself. So we knew somehow we had to have one of those identities that turns into cos 2x. Otherwise, it just wouldn't work. So there you go. There's question 1.3, and I hope that helps.